circled the top line under one-way slab, simple support, and wrote 13.5 next to it. Okay, that leaves us with 3 lines left. One end continuous, both ends continuous, and cantilever. Okay, our picture. This area right here, one end continuous. This end, there's nothing there, that one goes on. Mid-span, both ends continuous. So if you're here, you can go that way or that way. If you're on this end, you can go that way, but you can't go that way. And then a cantilever would be something like this, where the concrete slab cantilevers over and stops. Okay, if you look at those 3 cases, we're not going to deal with the cantilever at all. So you can put a line through that one. That leaves me 2 possible choices. One end continuous, both ends continuous. Okay, we're going to do this by process of elimination and logic. If you look at those, and you look at one end continuous for a 40 KSI piece of steel, you get L over 30. So for that one, the thickness is going to be L over 30. Okay, if you go right next door to it, you get 60, which is L over 24. Now go right below it. This is one end. One end. That's right here. Both ends. If you look at that, it's L over 35 and L over 28. Okay, out of those 2, we're going to have these 2 situations are going to run parallel to each other most of the time. So we're going to have that situation in just about every slab. Okay, if you take a look at that thing, and I ask you, if the span happens to remain constant, so this number and this number are exactly the same, which one of those 2 calculations would give you the biggest T? So I'm going to go for 15 feet, okay? So this is going to be 15 feet times 12 inches per foot divided by 30. This is going to be 15 feet by 12 inches per foot divided by 35. One of those 2 is always going to give you a bigger number. So if I take the first one, 15 times 12 divided by 30, 6 inches. If I take 15 divided by 12, or multiplied by 12, 15 times 12 divided by 35, I get 5.14 inches. Which one's going to give me the biggest thickness every time? This guy. Therefore, put a line through both ends continuous and circle the line that says one end continuous and put chapter 14 next to it. Okay, so this one right here is going to have chapter 14 written next to it. And this one and the cantilever are going to have a line through it. So you're going to have 2 possible lines, one for a simple slab, one for a continuous slab. First one is 13.5, the second one is chapter 14. So there's where we're going to go. That's how you choose what to do with the thickness based on deflection. So now we've got that out of the way, we ought to be able to move forward. So let's take a look at it. I'm going to start with letter A. Letter A, handout, says determine the minimum thickness. So let's look at it. I go to one end continuous, my steel is 60, so I go over to 60, and I see L over 24. So letter A, L over 24. Okay, here's a spot students who mess up most of the time. I have a 12 foot over there. Once again, on a test, I'm going to make this not 1 foot wide. Here they assume them to be 1 foot wide, so they've got this as 12 inches, 12 inches, and 12 inches. So my span is not 12 feet. It's 12 feet minus 6 inches on this side and 6 inches on that side. That's a foot. That pulls it down to 11-foot span. So my span is 11 foot. So span equals center to center minus the beam thickness in my case, that's going to be 12 feet minus 1 foot equals 11 feet. So there's my span. So 11 foot times 12 inches per foot divided by 24. My slab's going to be 5.5 inches. Okay, once again, on a test, this number will be to the nearest half inch. They're going to be 5, 5.5, 6, 6.57, and so on. It's not going to be a decimal. So if you get a decimal, rethink what you did. So we got a 5.5 inch slab based on deflection. So this is going to be 5.5 inches. That's our initial deflection thickness. Now all we got to do is worry about checking it, make sure that's good. If it's good, then we can worry about the steel. So let's move on to the next step. Next step is B. Check for flexure. Sound familiar? Same as we did for a simple slab. So the first two steps are basically the same, except for noting that the slab span is different. Clear on one, center to center on simple. So letter B, flexure. Okay, we got flexure. Check flexure. Determine the load on a 1 foot wide strip. The member will be a continuously supported slab with uniform load consisting of superimposed live and dead plus the weight of the concrete. So if I do that, I'm going to end up with 2 loads. W live load. W live load was what? 80. W dead load plus concrete. 40. There's the thickness of the slab, changed to feet, multiplied by the unit weight of concrete. So I'm going to take 5.5 divided by 12. 5.5 divided by 12, and I'm going to multiply it by 150, and I get 62.5. Add it to 40. So there's my superimposed dead plus weight of slab. So that got me through letter B. Move to letter C. Big U, which is really little WU in your world, 1.6 times 80 plus 1.2 times 102.5. Multiply those and I end up with a load per square foot, 1.6 times 80 plus 1.2 times 102.5, 251 pounds per square foot. Okay,